Hello and welcome again. In this video, I'm going to explain what factorization is and how we can factorize algebraic expressions. In math, when we're talking about factorization, it means bringing a larger number and breaking it down into smaller parts, or prime numbers. Now, and a prime number is a number that is only divisible by itself and 1. So let's say we take the number 20, okay? What we can do is we can write this as a product of 5 and 4, and we can bring 4 from 2 times by 2. And these numbers at the very bottom are prime numbers, okay? We can no longer further divide this. So we know that 2 times by 2 times by 5 is equal to 20. And these are the factors, okay? These are smaller parts that when multiplied together make up 20. We can do the same with algebraic terms. For example, we have x to the power of 4. We know that this is a product of x squared multiplied by x squared. And these can each be a product of x times by x and x times by x. So we know x times x times x times x is equal to x to the power of 4. If you want to learn more about indices and algebraic terms, you can see my other video on that. Getting back to factorization here, we have 2y plus 6. So what I like to do is I like to take the highest common factor of every term in the expression. So we have 2y plus 6. First, what we're going to do is take the highest common factor of 2 and 6. We know that 6 is a factor of 2 and 3, right? So the highest common factor that goes into 2 and 6 would be 2. So we're going to take 2 here. Now, as this number does not have a y, we cannot factor out the y as well. So what we're going to have here is 2, and then in a bracket, y, and now we're going to do 6 divided by 2, which is equal to 3, so plus 3. If you'd like to prove or make sure you've done the process right, you expand your bracket here. So we get 2 times y is 2y, 2 times 3 is 6. And that is the same as the beginning. So essentially what we're doing is we're taking out the common numbers or common terms from this expression and putting it to the right here. And then whatever is left, we're putting it in this bracket, okay? But you need to make sure that when you multiply the outside and the inside of the bracket, that you get the original expression. Let's take a look at this example. We have 6xy squared minus 9x squared y. So first we're going to see what is the highest number that goes into 6 and 9. So that would be 3. So we're going to write 3 over here. Now we're going to look at the second term, which is the x's. How many x's can go into both of them? So this, you have 1x, and here you have x squared. So that would be just 1x. Okay? Because this is x to the 1, remember. And now we have y terms. So the y squared and the y. The most amount of y's that can go into both is just 1. So y here. As this is y to the power of 1, remember? Now that we've taken all the amount of common factors from both terms, now we make our bracket, okay? So we're going to divide 6xy squared divided by 3xy. 6xy squared divided by 3xy. So 6 divided by 3 is 2. X divided by x, these cancel out. And y squared divided by y is simply y. So we get 2y in this part. Now we're going to do 9x squared y divided by 3xy. So we're going to get 9x squared y divided by 3xy. So we're going to get 9 divided by 3, which is 3, x squared divided by x, which is going to be x, and y divided by y cancels out. So we're going to be left with minus 3x, because remember we have a minus sign here, and that stays. Okay? And that would be our factorization of this algebraic expression. To prove that we've done this process right, we're now going to multiply our terms in the bracket. So we're going to do 3xy multiplied by 2y. So we're going to get 6xy squared, and now we're going to do 3xy times by minus 3x. So minus 3 times by 3 is minus 9. X times by x is x squared, and y times by 1 is simply y. And, as you can see, this matches our original expression, so we have factorized correctly. Let's take a look at one more example. Here we have 3a squared b plus 4ab squared. Now, we're first going to take the highest common factor of 3 and 4, but in this case, there is no common factor between 3 and 4. So, we're just going to skip over that term. So now it would be a squared and a, which would then be a as their highest common factor. Now b and b squared, that would be b as the highest common factor. And now we're going to make a bracket. Now, in fact, there is a common factor between 3 and 4, which is 1. But 1ab and ab is the same thing, so there is no need to write 1ab. But for the sense of learning, I will write it there. Now we're going to do 3a squared b divided by ab. 3 divided by 1 is still 3. A squared divided by a is a, and b divided by b cancels out. So this will be 3a. Now we're going to do 4ab squared divided by ab, which is equal to 4. The a's cancel out. B squared divided by b is still b. So plus 4b. And again, we can expand this to prove that it's correct. So 1ab times by 3a, that would give us 3a squared b, and ab times by 4b would be 4ab squared, which matches our original expression. Thank you for watching, and I'll see you all in the next one.